We are now at question 4 of this CXC CSEC January 2014 General Paper 2 exam video solution. And in this question we are given this diagram. It's a graph with 3 lines. Line 1 is this line, line 2 is this second line, and line 3 is this third line. And we are told that the equation of the 3 lines are y equals 2, y equals x, and y equals x plus 2. And the first part of the question wants us to correctly identify the equation of line 1, the equation of line 2, and the equation of line 3. That's part A. And if we look back at the standard form for the equation of a line, the equation of a line is of the form y equals mx plus c. And when the line is in the form y equals mx plus c, m is the gradient of the line, and c is the y-axis intercept of the line. And also, generally speaking, a line of the form y equals mx will pass through the origin, because in that case the c value is 0, and so lines of the form y equals mx are lines passing through the origin, because the c value, as I said, would be equal to 0. Lines of the form x equals a constant a, lines of the form x equals a, for example x equals 2, are vertical lines. The y-axis, for example, is the line x equals 0, and lines of the form y equals b, y equals a constant, are horizontal lines. And so, for example, the x-axis is the line y equals 0, and this line, line 3, is a horizontal line passing through 2, and so this line would be y equal 2. And so now, if we look at line 1, it crosses the y-axis at 2, and it also has a gradient. And so if we look at these 3 equations, the line which has a gradient and crosses the y-axis at 2, so the c value is 2, is this third line. And so line 1 is the line y equals x plus 2, and we can show that. And then line 2 is a line passing through the origin, and therefore it has the form y equals mx. And also this line has a gradient, and it's, as I said, of the form y equals mx. And if we look at these 3 lines, it must be this second one. And so line 2 is the line y equals x, and that's it. And then, as I said before, the horizontal line here, horizontal lines are of the form y equals a constant, and this line y equals 2, as I said, was line 3. It's a horizontal line crossing the y-axis at 2, and so line 3 is the line y equals 2. And so that's the answer for that part of the question. Let's move down now to part B. Now, what we have so far are the 3 lines, and we now know the identity of the 3 lines, and we can put that on the diagram. Y equals 2 is line 3, and so we can put that there. Y equals x is line 2, and we can also put the equation here on the line 2. That's it. And y equals x plus 2 is line 1, and so we can put the equation there on line 1, and that's it. And now we're asked to show that the gradient of line 2 is equal to 1. That's what part B is asking us, to show that the gradient of this line, y equals x, is equal to 1. Now, that line is y equals x, and remember, for any line y equals mx plus c, m is the gradient and c is the y-axis intercept. And so, since line 2 has the equation y equals x, it means that the constant m would be equal to 1. And so the gradient of this line y equals x is equal to 1. But we could also show that the gradient is equal to 1 by looking at the rise over run from one point to another point on the line. Gradient generally is equal to rise over run between 2 points on a straight line. And if we take these 2 points, for example, on the line y equals x, this point is at the origin, and this point has coordinates 2, 2. So this point is at the origin 0, 0, and this point is the point 2, 2. And if we look at the number of units that we rise from this point to this point, and also the number of units that we run from this point to this point, then we could calculate the gradient by dividing the rise over the run. And let's show that. And so this is the run and this is the rise. To go from this point to this point along the line y equal x, we would have to run 2 units to the right and rise 2 units upwards. And when the run is to the right, it has a positive value, and so this run is positive 2. And when the rise is upward, it also has a positive value, and so this rise is 2. That is, to go from this point to this point along the line y equals x, we rise 2 and we run 2. Run 2, rise 2. And so the gradient of this line, the rise is 2 and the run is also 2. Positive 2 in each case. And so that would give us the calculation for the gradient of the line y equals x. And so we see that answer is equal to 1. So we have shown that the gradient of the line y equals x is equal to 1. Let's move down now to part C. Now part C wants us to shade the region on the graph that describes this inequality, y greater than or equal to x plus 2. Now, the line that is associated with this inequality is the line y equals x plus 2. And this is it. And the greater than sign here means that we want the region above the line. The equal means that we want the line. And the greater than means that we want regions above the line. And so, we want the region that is above the line y equal x plus 2. And that's it. This inequality is referring to the region that is above the unbroken line y equals x plus 2. The line is unbroken in this case because the equal is a part of the inequality, and the greater than means that we want the region above the line. And so we can shade the region above the line y equals x plus 2 as the representation of this inequality. And that's it. Y values above this line will be greater than x plus 2. For a given x value, the y value in this shaded region will be greater than x plus 2, and for a given x value, the y value on the line will be equal to x plus 2, and therefore the line and the region above the line would satisfy this. And so we can also show that in the shaded region up here, the inequality would be y greater than x plus 2. For a given x value, the y value above this line will be greater than x plus 2. On the line, the y value will be equal to x plus 2 for a given x value. And so this shaded region, along with the line, represents the inequality y greater than or equal to x plus 2. And so that's the answer for this part. Let's move down now to part D. Now part D is asking us to state the 3 inequalities that define the shaded region S. This shaded region S. And so what we have to do to define the shaded region is look at the lines that bound the shaded region, and we will describe the shaded region in terms of the lines that are bounding the region. And the 3 lines that are bounding the region are this line y equals 2, this line y equals x, and the y-axis, which is x equals 0. And so firstly, the shaded region S is below the unbroken line y equals 2. And so y values in this region will be less than 2, and y values on this line will be equal to 2. And therefore, in relation to this line y equals 2, the shaded region will be such that y is less than or equal to 2. The shaded region is also above the line y equals x, and so y values in this region will be greater than x. Since on the line y values will be equal to x, in the shaded region y values will be greater than x. And so in the region above the line y values will be greater than x, and regions on this line y values will be equal to x. And so the shaded region, including this line y equals x, will be represented by the inequality y greater than or equal to x. The third line that is bounding this region is the y-axis, and the y-axis is the line x equals 0. And x values on the y-axis will be equal to 0, but x values in the shaded region will be greater than 0. And so in relation to the y-axis, which is the line x equals 0, the shaded region is taken as being above the line x equals 0, which is the y-axis, because as I said, in this region x values will be greater than 0, and on this y-axis x values will be equal to 0. And so the shaded region, including the line, will be such that x values will be greater than or equal to 0. And so that is the answer for this part of the question. The shaded region S, bounded by these three unbroken lines, satisfies these three inequalities. The shaded region S is such that y is less than or equal to 2 because the shaded region is below the unbroken line y equals 2. The shaded region S will also be such that y is greater than or equal to x because it is above the line y equals x and the line is unbroken. And the shaded region S is also such that x is greater than or equal to 0 because the shaded region S is to the right of the y-axis where x values are greater than 0, and at points on the y-axis x will be equal to 0. And so the region together with this line, the y-axis line, x will be greater than or equal to 0. So that's the answer for part D of this question. Let's move down now to part E. Now part E wants us to write the equation of a line which is perpendicular to line 1 and passes through the origin. Now remember that line 1 is the line y equals x plus 2. And that line that we're going to draw, the perpendicular line, we're going to call it line 4. So we want the line 4, that is perpendicular to this line 1 and also passes through the origin. And we can show that line. This is the line that we want. And because this line passes through the origin, it's going to take the form y equals mx, where m is a gradient, and so we need a gradient of line 4. And because we know that it is perpendicular to line 1, we can look at the relationship between perpendicular lines, and this is it. Perpendicular lines have negative reciprocal gradients, and so the gradient of line 4 is equal to the negative reciprocal of the gradient of line 1. And we already know that the gradient of line 1 is equal to 1, and we can show that the gradient of line 4, that's m4, is equal to negative 1 divided by the gradient of line 1, which is m1. So this calculation will give us the gradient of line 4, and we can show that now. And so that gradient of line 4 is negative 1 divided by 1, because 1 is the gradient of this line 1, and that works out to be negative 1. And we also know that the equation of a line through the origin, as I have said, is of the form y equals mx, because the c value would be equal to 0. And we now know that the gradient of line 4 is equal to negative 1, and we can therefore show that line 4 would be of the form y equals m4x, gradient of line 4 multiplied by x, y equals mx. And we have calculated the gradient of line 4 to be negative 1, and so we can substitute negative 1 here for the gradient of line 4. And therefore, the equation of line 4 is y equals minus 1 times x, which is the line y equals minus x. And so that's the answer for this part of the question, part E. And that's the end of this question 4. And we'll do question 5 in the next video. See you then.